Yeah, మీ స్క్రీన్ కనిపించట్లేదు నాకు.
Yeah, 1 minute. I'm showing. Okay, so what happened? There are mainly 3 interfaces, Sandy. One is list, set, map. These are the interfaces we have discussed already. So now I am segregating each one into either 2 or 3 classes. So these interfaces will define only the methods which has to be there within that. Okay, that is the purpose of interface. Interface will only tell what are the methods you should have in your class. The class which is implementing that interface has to write definition for those methods. So like that, this interface list is implemented by many classes. Currently we are discussing about only 2. One is array list, another one is linked list. Okay, so first we'll try to understand the difference between array list and linked list. Okay, so here if you take array list, internally it uses arrays only.
Okay.
So because of that it needs continuous memory locations. Do you know how will it work in arrays? If you define an array like this, integer array equal to new integer, I declared some 10. So it means that I need an integer array with 10 memory locations. Okay, if I make it as a, the reference name is a, then what will happen is it will create an array with 10 memory locations. Okay, so if the starting memory locations address is 120, he will store only this 120 in a equal to 120. He doesn't store all other memory addresses, because the advantage in arrays is they will maintain continuous memory locations, right? If first memory location address is 120, means next memory location address is 121, because they are continuous. Okay, next one is 122. So no need to carry the address of all the elements. If you hold the information about the memory address of the first element, by simply adding one you can get the next element. By simply adding one you can get the next element. Like that you can traverse the array. Okay, so since they are using arrays internally, array list also needs continuous memory locations. Okay, hello. Yeah, so you can say it as advantage. in one case we'll discuss. First we'll I will explain you linked list also. After that we will discuss the advantages in array list, advantages in linked list. Okay.
Okay.
Linked list is a structure like this. It contains a node. Okay. Each node contains value and address of the next element.
Okay.
Okay, they don't use continuous memory locations. Okay, so that's why they will maintain the address of the next element also. Since here
Okay.
in arrays they are continuous, right? By simply adding one you are getting the next element, but in case of linked list they are not continuous. That's why they will maintain the address of the next element.
Okay.
Okay, so if you have 1 2 3 4 5 values, and if you want to place it in integer array, you will make it like this. 1 2, you will create an array, you will place 1 2 3 4 5 like that. But in case of linked list you will place like this: 1, some address 100,
Okay.
then he will create 2 somewhere, its address is some 140, then he will place that 140 here. Okay, so this will make the link to the next location. Then he will create 3. He will create a node and he will place the address 3. So it is created somewhere in 260. Okay. He will place this 260 here. Okay. Like that, in each element along with its value, he will maintain the address of the next element. Okay.
Okay.
So now we will compare the advantages and disadvantages of the 1 minute, Swati. చెప్పండి.
Yeah.
Hello.
Yeah. Super.
Yeah. Uh, so for every element along with its value, it will maintain the address of the next element. Now we will try to understand the advantages of array list and linked list. When compared to array list, linked list will take much memory because
Okay.
along with the value, it's holding the address of the next element, right?
Yes.
So when compared to array list, linked list will take more memory. This is the disadvantage of the linked list. This is the advantage of the array list. Okay.
Okay.
But the advantage of linked list is I am planning to create an array of 10 elements. Okay. I have 6 vacant locations at one place and I have 7 vacant positions at another place. Okay.
Okay.
So there are 13 vacant locations for us. Even then you can't create an array because array needs 10 continuous memory locations.
Yes.
Here we have 13 vacant locations. Even then we are not able to create an array because they are not continuous. But you can create an array with linked list. You can create a list with linked list because it will use memory locations even they are not continuous because it's simply making connections, right?
Yes.
So that is the advantage of the linked list. Even the memory locations are not continuous, it can create a list. But in array list, memory location should be continuous. Even
Okay.
enough vacant memory locations are there. If they are not continuous, you can't create a list using array list.
Okay.
No, these are the advantages and disadvantages, and we should know right when to declare array list, when to declare linked list. Okay.
Okay.
Uh, so I will take one more. So the concept here is you have an array list. Internally, it is implemented using errors, right? Okay. So in arrays, you placed 6 elements here, like this, 7 elements. Okay. You are deleting this element, number 3. Okay.
Okay.
Then what you supposed to do is you should delete this element and you should shift all the elements in the array by one position. 7 null. Okay. Here we have taken an array of 7 elements. So it took 4 operations for us to shift the array. But if you take an array of 1 lakh elements, what will happen? You need to make around 1 lakh operations, right? To shift the array, to rearrange the array.
Yes, yes.
And in deletion also, in inserting an element also, if someone asks you to insert some 10 here, what you supposed to do is first you should shift the array to make that location vacant.
Yes.
First you should shift this 7 to null position, then you should shift 6 to 7 position, and 5 to 6 position,
Right.
4 to 5 position, and first you should make this position vacant. Then only you can insert the new element 10. Okay. Here also we have taken an array of 7 elements. If you assume that array size is 1 lakh, you need to make around 1 lakh arrangements nearly to insert the elements. But if you insert an element using linked list, we'll see what will happen. Even you assume 1 lakh elements. So I have my linked list like this. This is 100. This is my value 1. This is 200. This is 200. My value is 2. 300. This is 300. My value is 3. This is 400. My value is 4. Okay, null means end of the list. Okay, like this linked list will be created in memory. We'll see. Someone asked me to insert value 10 here, in between 2 and 3. Okay.
Okay.
I created a value 10. It is created at a location some 450. Okay. So if I want to insert, so no need to rearrange the entire list. So what I supposed to do is I need to replace this 300 with this 450. Okay.
Okay.
Then connection will be formed to this element and I need to place this 300 here.
Okay.
So it will be pointed to this. So this 10 is inserted, right, in between 2 and 3.
Yes.
So by simply replacing the address of the first element and placing the address of the second element in the new element, I can insert the element. Irrespective of the list length, I can changing the addresses of the elements, I can insert an element in linked list. You got it?
Yeah, I got it.
Even deletion also works in the same way. If you want to delete some element, so if someone asked me to delete this node, what will I do? I will simply replace the 300 with 400.
Yeah.
So connection will be formed here, right? So by simply overwriting the addresses of the previous element, you can simply insert the elements, delete the elements irrespective of the list size. So insertion and deletions are very costly in array list.
Okay.
They will take lot of time. So in your class, if you are performing more insertion and deletion operations, go ahead with linked list. Don't use array list. Got it?
Yeah. Okay.
Have it in your mind when you are using some class, and if you are doing more insertion and deletion operations within that class, don't use array list. Just go ahead with linked list. So we finished the differences between array list and linked list. Now I am noting down the important classes which are implementing set. There are mainly three classes which will assist our needs. One is hash set, second one is linked hash set, third one is tree set. Now we will try to understand the differences between hash set, linked hash set and tree set. Okay. I have created a list. I have created a set of strings. I named it as names. My list name is names. So for these names, here I didn't initialize, but we'll initialize some hash set or tree set or linked hash set we will do. So here I am adding a few names. I added D, then I added E, then I added C, then I added F, then B, then A. So I added 6 names. Okay.
Okay.
If I try to print the list, hash set will return different values for each run. So if I print the list first time, it might return D, F, E, B, A, C, something like that it can return. Okay.
Okay.
If I execute it again, it might return some other order. So in hash set, order is not guaranteed. In which order it will return the elements, no one can say that. It is up to the JVM. It will return one order at a time. No one can guarantee the order in hash set. Okay. But if you use linked hash set, it will return the elements in the order in which they are entered. Means you entered D first, right? Then E, then C, then F, then B, then A, right? So it will retain the same order. D, E, C, F, B, A. Even you run it the program 100 times, it will return you the same order again and again. Okay?
Okay.
That means linked hash set will maintain the order in which you are entering the elements. Okay? Tree set is a sorted set. Whatever the order you follow to enter the elements, it will sort it. It doesn't bother in which order you entered. Finally, it will return you this A, B, C, D, E, F. Okay?
Okay.
So, you can say it like this. Hash set is neither ordered nor sorted. Linked hash set is ordered one. That means the order in which you are entering the element, it will maintain and it will return the same order again and again. Tree set is sorted set. Irrespective of the order in which you have entered, it will sort the elements and will display the list.
Okay.
Okay? We'll see it through programs. It's the theoretical definition, but I don't want to tell you the theories. See, this is my hash set. I am adding 5 names here.
Okay.
So I added Chan first, then I added Raghu, then I added Bilva, right?
Yes.
But Raghu
It
came
changed it.
prior to Bilva. Okay? Then Bilva came.
Okay.
And Raghu 2 came. Then Bilva 2 came.
Mm-hmm.
Okay? Like that,
Okay.
it doesn't follow the order in which I have entered the element and the list is not sorted. The set is not sorted. Okay?
Okay.
We will see what will happen if I use linked hash set. See, Chan came first, then Bilva, then Raghu, then Bilva to Raghu 2. The order in which you have entered the element in the same order displaying. So it retains the order. Okay.
Okay.
If you run it again also it will return the same. For n number of run cycles it will the output is constant. It will return the same order. Chanu, Bilva, Raghu, Bilva to Raghu 2. Okay.
Okay.
And now I will run the same program with tree set. It is sorted. Bilva, Bilva 2, Chan, Raghu, Raghu 2. Okay.
Okay.
The difference here is here you are declaring it as set. That is the interface. But the implementation will change based on the object you are declaring. Here I declared it as tree set.
Okay.
Here I declared it as hash set. Here I declared it as linked hash set. Okay.
Okay.
So it depends on you in which set implementation you will take. If you don't need any sorted list, like in real time our need will change, right? Your manager
Yes.
asked you to print a list of names in a sorted order,
Yes.
then just go ahead with the tree set because uh, uh, sorting a list at the time of adding itself is bit easier when compared to sorting an unsorted list.
Yes. Mm-hmm.
Did you get what I am trying to say?
Yeah. Yeah. I got it.
Yeah. So based on your requirement, if you want to, if you want a sorted list, just go ahead with reset. Don't no, don't use hash set and try to sort it later. If you don't need a sorted list, then don't use tree set because when compared to hash set, tree set will take a bit more time to add the elements because at the time of adding it is trying to sort, right?
Yes. Mm-hmm.
So based on your need only, you need to pick up one of the set implementation. If your
Oh.
manager asked you to print the elements in the order, like he is asking you to go through all the customer requests,
Okay.
and
Mm-hmm.
he asked you to serve it as first come first serve.
Okay.
So then you need to maintain the order, right? In which order the request comes, in the same order you should serve.
Yes. Mm-hmm.
In such cases, you will go ahead with the linked asset. It purely depends on your requirement. Based on the requirement, you should use one of those implementations.
Oh.
So if you know the differences, then only you can choose the correct one. That's why I'm telling you.
Okay. Yes. I got it.
You got it right?
Yes. Yes. I got it.
Now we'll go ahead with map. So if you get the differences between hash set, linked hash set, tree set, then it's bit easy because it's similar to that. Here also the names are also similar. The main three implementations of map are hash map, linked hash map, tree map. So as we discussed earlier, map means key value pairs, right? So in hash map, all keys are neither sorted nor ordered.
Okay.
In linked hash map, all the keys are ordered. In the order you have entered the elements, in the same order keys will be returned.
Okay.
In tree map, all the keys are sorted.
Okay.
So see, I entered Sujita first, then Teja, then Anusha, but their keys are 5, 2, 7.
Okay.
But this is tree map, right?
Yes. Mm-hmm.
That's why it sorted the map based on the keys. So 2 came first, 5 came second, then 7 came last. 2, 5, 7. Okay.
Okay.
Now I am trying with linked hash map. So the same order it returned 5 to 7.
Five.
Okay.
Okay.
If you use hash map, it might return 5 to 7, but you can't guarantee it because it is, I told you right, it will
Yeah.
give random orders.
Uh,
In one of the random case, it might return 5 to 7, but you can't guarantee it. See, now it returned 2, 5, 7. It doesn't mean that it
yeah.
sorted the list. It is one of the random order given by hash map. If you run it again, it might return new sequence. I will add one more number, then it will give us. See, 69 came first, 2 came next, then 5 came, then 7 came, then 15 came. Okay? It is neither ordered nor sorted. Clear, right?
Yeah, I got it.
So, this is the main differences among the implementations of these interfaces.
Okay.
This is all about collections. You should keep all the things in your mind to choose particular implementation based on your need. Okay.
Okay.
For reference, you can use this in my blog. If you go here, there are categories. If you click on collections in Java, it will show you. This is for core Java students. It's not needed for you. If you are interested, you can go through it. So all other differences will be placed here. The difference between hash map, linked hash map, tree map. Keys in hash map are neither ordered nor sorted. Keys in linked hash map are ordered. Tree map are sorted. Difference between hash map, tree map. These are unsorted. These are sorted. Like a hash set, a linked hash set. It will be explained with an example also. I explained it. Sorry. So you can go through it for reference. Now we will see exceptions. What does it mean by exceptions? Yeah. By tomorrow class we can finish Java. Okay, now we have exception handling there. Exception handling also I can cover in this class, I guess. Do you have Eclipse with you, Swati?
Internet?
Do you have Eclipse with you?
Yes, I do. Yeah, I install Eclipse.
ఓకే, మీరు ఎక్లిప్స్ సెటప్ చేసుకోండి. మీకు ఏదన్నా ప్రాబ్లం వస్తే నేను చేసి పెడతాను. ఎందుకంటే రేపు పొద్దున హ్యాండ్లింగ్ ప్రాపర్టీ టెక్స్ట్ అండ్ ఎక్స్ఎల్ఎస్ ఫైల్స్ అన్నా కదా, ఇది థియరీ పార్ట్ కాదు, జస్ట్ ప్రోగ్రామింగ్. హ్యాండ్లింగ్ అంటే మీన్ టు సే హౌ టు రీడ్ ద ప్రాపర్టీ ఫైల్స్, హౌ టు రీడ్ టెక్స్ట్ ఫైల్స్, హౌ టు రీడ్ ఎక్స్ఎల్ఎస్ ఫైల్స్ అనమాట. ఎందుకంటే ఇన్ అవర్ టెస్ట్ కేసెస్ విల్ గివ్ ఇన్పుట్స్ త్రూ దీస్ ఫైల్స్. ఎయిదర్ యూ విల్ యూజ్ ప్రాపర్టీ ఫైల్ or text file or XLS file to give the inputs. So you should know how to read the files using Java. సో నేను రేపొద్దున ప్రోగ్రామ్ రాసి చూపిస్తాను. మీరు కూడా ఏం చేస్తారు అంటే ఎక్లిప్స్ మీరు సెటప్ చేసుకోండి. చేయలేకపోతే కనుక నాకు కంట్రోల్ ఇస్తే నేను చేసి పెడతాను మీకు. ఓకే, అయితే రేపొద్దున ట్రై చేద్దాం. అయితే మీ ఎక్లిప్స్ లో ప్రోగ్రామ్స్ అసలు మీ ఎక్లిప్స్ లోనే రాస్తాను. అయితే we'll try to understand how to read the property files, text files and XLS files in tomorrow class. Today I will explain exceptions.
Okay.
So exceptions in Java. First we need to understand there are two terms only. One is error, another one is exception. Okay, first we need to understand the difference between error and exception. See, error means error is an irrecoverable condition occurring at runtime. Exceptions are the conditions that occur because of the bad input. So let me explain with good example. So if someone asks you the configuration, do you have laptop with you?
Yes, I do.
What is the configuration?
It's 8 GB and
okay, 8 GB is the RAM, right? What is the how much hard disk you have?
hard disk is about, I think, 2 GB or 4 GB. I don't remember the exact figure.
So okay, leave it. My question is, what is the difference between RAM and hard disk? In hard disk you will place songs, movies, games, everything, right?
Yes.
But in RAM what are you putting? You said it's 8 GB. That means you can place more than 8 movies, but you are not utilizing the space. Are you able to see RAM? What is the purpose of RAM in programming? No, why do we need RAM in laptops?
It's for the efficiency of the laptop, for more speed.
Yeah, I agree with you. If your RAM is good, that means if your RAM is 8 GB, it will perform better than 4 GB RAM. I agree. I'm asking what is the need of RAM? Who will use that RAM? We are not using it, right? In RAM we are not placing any movies, files and all. You are not able to utilize the RAM. I'm pretty sure about that. Then who will use that RAM?
System
Yeah, system will use it. For what?
for system files or something like that.
No, no, it's not about system files. Here, um, uh, in our previous classes we discussed it, right? I am creating an employee class. Okay.
Mm-hmm.
In that I am setting properties like name, age and all. Okay. So
Okay.
according to Java, we are discussing like a character will take 1 byte, integer will take 2 bytes, like it is taking 32 bits. That means int will take 2 bytes, right?
Mm-hmm.
1 byte, 2 byte, it is also memory, right?
Yeah.
If you create 1 lakh objects, that means 1 lakh bytes. Uh, for holding the IDs of the employees, you are utilizing around 2 lakh, 3 lakh bytes.
Okay.
So if you create more and more objects, if you create more and more strings, if you create more and more integers, you need uh, uh, a memory of around 100 KB or 100 MB, like that. So where you are creating all these objects means you are creating all these objects in your RAM.
Okay.
All the programs you are running will utilize the RAM space to create these objects.
Okay.
I am talking about Java. That's why I told that it's utilizing RAM. I explained with the objects, but all other program, all other softwares you have installed in your laptop will utilize the same RAM for their execution. Like you have Windows Media Player, you have Eclipse, you have this, right? You have uh, all the softwares like Notepad++, like Microsoft Word, everything. What I have opened in my laptop are utilizing the RAM to perform the actions, whatever they supposed to perform. Okay.
Okay.
If you go to Task Manager, see these are the processes what I have. So my Eclipse is taking too much, like 489 228K. So
Mm-hmm.
this is my RAM space. Mm, this is the picture of utilization of my RAM by different processors. My Eclipse is taking too much memory. It's consuming too much memory from my RAM. Then Chrome is consuming. So this is GoToMeeting G2M. This is the processor related to GoToMeeting, I guess. It's taking 168 300K. Okay. You can see the performance. Here I have 4 GB RAM. Around 2 GB is consumed by all these processes.
Okay.
So that is the purpose of RAM. So
Oh,
why I explained RAM is in our Java for every program 256 MB is allocated by default. 256
okay.
MB memory will be allocated. So for each program, as I said, 256 MB will be allocated. So within that memory, you should create your object, strings, integers, etc. etc. And there is some argument like xmx. Using that, you can increase it till 1024 MB. That means you can make it 1 GB also. Okay.
Okay.
For now, we will forget about this. We assume that only 256 MB is allocated to my program, but
Okay.
I am utilizing 300 MB. I need around 300 MB space to create all my objects. Okay.
Mm-hmm.
So then what will happen till 256 MB it will create the objects. Once
Okay.
it exceeds 256 MB it will throw you out of memory error.
Yeah. Mm-hmm.
You are utilizing more memory than what available for you, what is available for you. These are called errors because at the time of the error you can't do anything because you have 256 MB and you are utilizing more than that. You can't change your RAM right away, right?
Yeah. Mm-hmm.
At the time itself you can't change the RAM. So these are called errors. If you
Yes.
can't handle it, that is called error.
Okay.
Okay. Now we will try to understand what does it mean by exception. So I'm having a new class. I have a D drive. In that I have it document. Swati. So I forgot in which directory I placed it. It might be in D directory or it would be in E directory. I placed in
Okay.
one of the directories. I don't know whether it is E or D. Okay.
Okay.
So I am trying to read the file. It is asking me to either add those or surround something. So I am adding it. These are called exceptions.
Mm-hmm.
No, see here, it's throwing some exception, file not found. Okay, in E drive there is no file named Swati.
Yes. Mm-hmm.
So there is no file. Okay, if there is no file in E directory, you can do something, right? It is not the end of the program. If you don't find the file here, find it somewhere. You can tell to the program like that. If you don't find the file in E directory, then ignore it. Like that also you can tell. It's your
Okay.
choice.
Yes.
So these are called exceptions. If you are some problem occurred and if you are if you are able to handle that problem, that is called exception. If you are not able to handle it, that is called error. Okay. See here
So,
a problem occurred, right? See in which way I will solve it. I will catch this exception, file and find. So find it in. So no exception occurred because it's there in D directory. So if some problem occurs, if you are in a position to handle it, that is called exception. To handle exceptions, Java provided these try-catch blocks. So the condition because of which there might be a chance of occurrence of exception, you should place that code in try block. Whatever the actions you need to perform at the occurrence of exception, you need to place in catch block. If you want to ignore it, you can ignore it. Instead of checking in D drive, if you want to ignore it, you can simply print ignore the file. Ignore the file and you can continue with rest of the program. You can write whatever you want here. Okay. These are called exceptions. So there is one more block called finally. The purpose of finally is, so here some exception will come. You want to print M here. Okay. After this you want to print M, but you can't print M because at this line itself exception came and code enters this block. Okay. So if you want to print M here, then you will place it here. Okay. But I gave the location as D colon Swati. I didn't place M here. Run as Java application. Now in this case also I am not able to print M because exception didn't come. That means program execution doesn't enter this code block. So if exception comes, then catch block will be executed. If exception doesn't come, then only try block will be executed. But I don't know whether exception will come or not. Irrespective of the exception, if I want to run some statements, I will place it in finally block. So irrespective of the exception occurrence, it will run the code in the finally block. If you see here, I am able to print M. I will make it as E. Now exception will come. Run as Java application. See, because of the exception only, I am able to print ignore the file, and I printed M also because it is in finally block. So the purpose of finally block is, irrespective of the exception, you can run the code within finally block. Okay, Swati?
Yeah, got it.
So what does it mean by exception? What does it mean by error? I'm asking you. Hello?
Exceptions are the one which we can handle it.
Yeah, that's it. Errors are the ones which you can't handle it. Yeah, that's it. Definition is good. So exceptional condition that occur because of bad input and you can handle it. And there are two types, Swati, in exceptions. One is checked exception, another one is unchecked exceptions. Okay. Checked exception means it will ask you to handle it, like file not found exception. It asked, right, either throw or catch it, like that it asked us, right? That is called checked exception. Forcing the end user to handle it is called checked exceptions. Okay. If you don't throw it, it will ask you either add the throw statement or surround with the try catch. Okay. These are called checked exceptions. See here. int I equal to 1/0. It doesn't ask you to throw any exception. It doesn't ask you to handle it. But if you run the program, it will throw arithmetic exception. You can't divide the element by 0. These are called runtime exceptions. Because if file doesn't find, if you doesn't find the file, you can handle it, right? You can set somewhere, or you can ignore that. That's why I am forcing you to take some decision. What will you do if I don't find the file? That's why I made it as checked exception. But if you divide some element by 0, you can't handle it within the program. You should change the program, right?
Yes.
So the exceptions which will come due to the mistakes in the programming logic will come under runtime exception.
Okay.
They will simply thrown by Java at runtime.
Okay.
It doesn't ask you to handle it when you are programming itself. But checked exceptions are not like that. At the programming time itself, you should take a decision to handle them. That is the difference between checked and unchecked exceptions. Unchecked exceptions you can also term it as runtime exceptions because they will occur only at runtime. They don't ask you to handle it at the programming time. Okay?
Okay.
They will come because of the mistakes what you do in your programming logic.
Okay. Then what is the solution for runtime errors?
Runtime errors, you should change your program. So I ran this program, right? So I got the error. So I need to change it. Don't divide it by 2. Don't divide it by 0. Make it as 2. So after your first execution, you will come across that exception, right? After seeing that exception, you need to change your code. You need to change your program. It is definitely due to the mistake you have committed in your program, right? That mistake you supposed to correct it after the first execution and you can run it.
Okay.
Okay? So checked exceptions are exceptions which forces the program to catch them explicitly in try-catch block. And what is the difference between checked and unchecked is all the exceptions which are extending exception is known as checked exceptions. Like there is a tree for exceptions. There is a top class named throwable. This is error. This is exception. Okay. In exception, there is a subclass named runtime exception. Okay, if you define any exception as subclass of this runtime exception, new exception which extends runtime exception, that is called unchecked exception. In this way, Java distinguish checked exceptions and unchecked exceptions. So all the other classes of exception will be treated as checked exceptions. Okay. Only the subclasses of runtime exception are treated as unchecked exceptions.
Okay.
Okay. If you see, we have seen arithmetic exception, right? That is a checked exception. If you see here, that is unchecked exception. If you see here, it is extending runtime exception. Okay.
Okay.
Null pointer exception is a runtime exception. It is also extending runtime exception. Okay. So these are unchecked exceptions. It doesn't ask you to handle it at the programming time. Control Shift T.
Okay.
We have seen file not found exception, right?
Yeah, fine.
Yeah, this is extending IO exception. If you see the tree, control, if you click on Control T in Eclipse, it will show you the type hierarchy, part of the parent class. File not found,
Okay.
IO exception, exception. So as we discussed now, all the subclasses of exception will come under checked exceptions, except
Okay.
if they are subclass of runtime exception. If you see runtime exception in the tree, that is called unchecked exception. If you don't see runtime exception in the tree, that is called checked exception. Here you are not seeing right runtime exception in the tree, that's why it is a checked exception. Okay. At the time of programming itself, you should handle it. Either you should throw it or you should catch it.
Okay.
If you see the type hierarchy of null point exception, in middle runtime exception is there. So it is a unchecked exception.
Yeah.
Control T. Here also runtime exception is there. So it is called unchecked exception. So subclass of runtime exception will be treated as unchecked exception. Example, arithmetic exception. All subclass of exception except subclass of runtime exception will be treated as checked exception. Okay, clear? So we can create custom exceptions also, Swati. It is also very important for us. It's already 8:40. I will tell you the purpose of custom exceptions in the next class. I can finish it within 10 minutes, I guess. After that, we will have the class on handling these property text and XLS files. We will do that programming only in your Eclipse.
Okay.
By tomorrow, we'll try to finish Java and we will go ahead with JUnit. Okay?
Yeah. Okay. Fine.
You are clear, right? You don't have
Yeah,
any doubt?
I understand everything.
Oh, okay, sorry. Thanks. So
Yeah. Thank you.
I'm closing this session. Okay?